Hello, guys. This is Prime Concept, and I'm here again to take you on the basics of electricity. I'll be introducing electricity from the basics such that we can build from that foundation. And if you follow my series from this, you would get the basics of electricity very clearly. Now, one of the things we want to do under electricity is to understand the components in electricity. And those days, when some of us were growing up, one of the simple experiments we used to conduct under electricity was to bring a light bulb, a touch bulb, to bring a bulb like this and connect that bulb through a wire, connect it to a battery. So we had our battery like this, connect it, connect it to the other end of the battery, and this touch bulb would glow. Now, not unknowing to us that we have actually built or constructed an electric or electronic circuit. Now, this thing we see here, we can translate this into a standard form of electrical circuit, right? Now, before we start doing that, one of the things we want to learn is what are the components and the symbols that are used for electrical components. So, we're going to start this way. We're still going to translate this into an electric circuit, but let's learn the circuit symbols. One of the first things you want to know in electricity in components is that we have a wire. A wire in electric circuit is denoted by lines, straight lines. So this is a wire in electricity. Lines, we can bend them. So this is a wire. Then another thing you need to know is resistor, the symbol for a resistor. We have two symbols, circuit symbols for resistors that can be used. One circuit symbol is this. So this is one circuit symbol for a resistor, or we can say this is another circuit symbol for a resistor. So this is a resistor. So this is a circuit symbol for resistor. Now know that these are standard resistors. These are fixed resistors. Standard resistors are resistors whose values are fixed. Their values cannot be changed. So these are standard resistors. So we still have what we call a variable resistor. Maybe I should include that. Number three. So when you have something like this and you have a slash here, or say you have this, you have this, so this becomes a variable resistor. Variable resistor. So this is it. But this is the one we'll be meeting more in our circuit analysis for now, our basic circuit analysis for now. Now, number four, we have an inductor. An inductor is also a circuit component. So, and this is the symbol for an inductor, a coil of wire. An inductor is a coil of wire. So this is an inductor. An inductor. In our later videos, we'll be explaining what each of these components means. But then an inductor is simply a device that stores charge or that stores energy in a magnetic field. That is an inductor. Number five, we have a capacitor. So capacitor also has two symbols. So this is one symbol for capacitor. And we have another symbol, which is this. This is another symbol for capacitor. So for now, both of them are the same. But actually, this is a non-polarized capacitor symbol. But this is a polarized capacitor symbol. But this is what we'll be seeing more. So this is symbol for capacitor. So this is a capacitor. So these are some of the basic circuit components. Then let's say number six, we'll have our symbol for battery. So the battery symbol, which is a long terminal and a short terminal. Note the difference between a capacitor and a battery. So for a capacitor, the two terminals are equal. For a battery, one terminal is long and the other terminal is short. So understand. So for a battery, the long terminal is actually our positive terminal. And then the short terminal is our negative terminal. So this is the symbol for a battery. So these are the basic components we'll be meeting. Okay, maybe I should add a few more. So I'll rub this, say number seven here. Number 7, we have a voltmeter. A voltmeter is an instrument that is used to measure voltage in a circuit. So we have a voltmeter. Voltmeter is usually denoted with this, a circle with V inside. So that is a voltmeter. We have number 8. We have number 8. We have an ammeter. An ammeter, this is a voltmeter. Voltmeter. This one is ammeter. An ammeter is an instrument that is used to measure current flowing through a circuit. That is an ammeter. We also have, remember this battery we have here, battery is simply a source of direct electricity. That is what battery gives us, DC, direct electricity. We also have a source for alternating current. So we have number 9. If you have something like this and you have this simply means AC voltage source. So this is an alternating voltage source. So you have this. So these are basic electric symbols in a circuit. So we'll be using these symbols, putting them together to draw some circuit. Now, from what I initially explained, I gave a simple illustration of a circuit with a bulb and then connected to a battery. So we're going to draw that using the electrical symbols we have learned. So we're going to see how to change that into a circuit, into an electric circuit. Now, in electricity, one thing you should understand is that a bulb is denoted as a load. A bulb for an electric circuit is a load, or you can call it a resistance. So remember, this is what we earlier had, our bulb. This is what we earlier had. This is our bulb. And then we connected it via a wire to a battery. This is what we earlier had. Now, if I want to draw the circuit equivalent, electric circuit for this, I'll be denoting this bulb as a load or a resistance. Then this is my battery. So this would simply mean I have my load. This is my load, which is the bulb. Then being connected to a battery, which is this. So this is what we have. So this is my battery or my voltage source, my EMF, and this is the bulb, which is the load now, serving as a resistance. Then you have your current I flowing through the circuit. So this is the circuit equivalent for this. So thank you. I believe that this concept is very clear. Now, in our next video, we'll be learning how to analyze circuits, learning some of the things that are involved in an electric circuit. We'll understand what EMF is, we'll understand what resistance is, and we'll begin to learn how these resistors can be arranged in a circuit. We can have parallel arrangement, we can have series arrangement. So we'll be learning how these things can be arranged in a situation where you have more than one resistance. How do you combine them so you can still arrive at a single circuit? Because the aim in circuit analysis is to be able to reduce any complex circuit to become a circuit that contains only one resistor, so that you can easily apply Ohm's law. Thank you. In my next video, I will explain further under the electrical concept. Thank you for watching my video. Follow my channel to get more inspiring videos in physics, mathematics, and others. Thanks.